Okay, so we're going to be taking a look at a kinematics question that requires us to use calculus to solve the problem. So as part of high school physics, you probably would have seen some equations that look something like this for our kinematics section, which relate the position, velocity, and acceleration at time. So these equations you can only use when you have a constant acceleration. Anytime you don't have a constant acceleration, these equations don't apply. So in this case here, for this question, they give us an equation for the position in terms of time. So we don't necessarily know what the acceleration is or whether it's constant or not. So a safer bet for this question is just to disregard these equations and just kind of start from scratch here to come up with our equations for acceleration and velocity. So the question here says the position s in meters of a body at time t in seconds is given by the following equation. Find the body's acceleration every time the velocity is 0. So what they want us to do here is figure out what is the time in seconds when the velocity is equal to 0. And then once you figure that out, figure out what the acceleration is going to be at those times. So first thing we need to do is come up with the equation for a velocity. So what we could do there is we can take the equation for the position, take the derivative with respect to time, and that's going to give us our velocity with respect to time. So we take the derivative of this equation here. That 3 is going to come down out front there, so that's going to be 3t, and then the power 3 is going to drop down to a 2, so that'll be 3t squared. The minus 6t, that's going to turn into minus 12t. And the plus 9t, that's going to turn into plus 9. Okay, so now that we've got our equation for velocity in terms of time, what we could do is set that equation equal to 0. So I'll just say velocity is a function of time equals 0. Okay, I'm just going to copy and paste this down here. There we go. So then from there, we can factor this equation. So if we divide everything by 3 here, that's going to simplify this a little bit. So that 0 is going to stay at 0. We divide by 3, and that's going to give us t squared minus 4t plus 3. So we could have used the quadratic equation here as well, but I find that equation a little clumsy, so I like to try and factor it if I can, and if I can't, then fall back on the quadratic equation. So if we try to factor this, what we're going to be doing is we're looking for two numbers that multiply together to get positive 3 that add together to get minus 4. So for us, that's going to be t minus 3 and t minus 1. And then once I write this out, I always just double check. T times t is t squared. We'll get the minus 3 and the minus 1. That's going to give us minus 4. And then multiplied together will be plus 3. Okay, that looks good. So that means that in order for our velocity to equal 0, our time has to be equal to 1 or 3 seconds. So now that we figured that out, the next step we need to do here is come up with an equation for our acceleration and then plug those times that we just found into that equation. So in order to do that, we can take the derivative of our velocity with respect to time. And that's going to be our equation for our acceleration. So if we take a look at our velocity equation and take the derivative of that, that first term there is just going to turn into 6t. That second one there is just going to turn into 12. And the plus 9 at the end there is just going to go to 0 because it's a constant value. Okay, so now we've got our acceleration equation. We can plug in those times that we just solved for and figure out those accelerations. So acceleration when the time is equal to 1, that's going to be 6 times 1 minus 12. And that's going to be equal to minus 6 meters per second squared. Then we could do the same thing with the other time that we solved, which was 3. So that one's going to be 6 times 3 minus 12. And that's going to give us positive 6 meters per second squared. And so those are our 2 final answers. So the times that the velocity is equal to 0 is 1 and 3 seconds. And the acceleration at those times is going to be minus 6 meters per second squared and positive 6 meters per second squared. So for this question, the key to solving this one is to throw away those old equations from high school and pull out the new calculus versions of those ones. And so what we really need to know is that if we have an equation for position, we can take the derivative of that with respect to time to get velocity. And if we have an equation for velocity, we can take the derivative of that with respect to time to get acceleration. So this problem came from my ebook, which I'll link below if you want to check it out. It has a bunch of practice problems with answers in the back for university level physics problems.